Have you ever stopped to wonder what makes the camera on your phone just so good? Or how your car knows the exact pressure in your tires? Well, the secret is these tiny little things called sensors. But how do we know if a sensor is any good? Turns out, every single one has its own kind of report card. And today, we're going to learn how to read it.
I mean, think about it. We're surrounded by devices that are constantly sensing the world around us. They're measuring temperature, light, motion, pressure, you name it. But how can we actually know how good they are at their job? How well do they really see or hear or feel? That's the question we're going to dig into today.
So, here's how we're going to break it all down. We'll start with this idea of a report card. Then, we'll get into the two most important grades on it, accuracy versus precision. After that, we'll look at how a sensor actually reads an input, talk about some of the glitches you see in the real world, define its limits, and finally, wrap it all up with why any of these grades matter in the first place.
All right, so first up is this report card idea. In the world of engineering, the grades we give a sensor are called its static characteristics. This is basically how we judge its performance when things are nice and stable, not changing all over the place.
And here's the more official definition. Think of it this way. Before you test how a sensor handles, a sudden spike in temperature, you first need to see how it behaves when the room temperature is just holding perfectly steady. This gives us a baseline, a foundation for figuring out how good it really is. Okay, now for the big one. Let's get into the two most famous and honestly most confused items on this report card: accuracy versus precision. Getting this right is absolutely fundamental to understanding how any sensor works.
And it is so important to get this straight. They are not the same thing. Not at all. Accuracy is all about being correct. It's how close you are to the actual true value. Precision, on the other hand, is all about being consistent. It's how close your measurements are to each other, even if they're all totally wrong.
The dartboard analogy just explains this perfectly. High accuracy and high precision, that's the dream, right? All your darts are right in the bullseye, every single time. But you could also have low accuracy and high precision. See how all the darts are clustered together? They're consistent, but they're way off center. They're precisely wrong. And you could even be accurate but not precise, where the darts are scattered all around the bullseye. Your average is good, but any single throw is a bit of a guess.
All right, next section. Let's look at how a sensor actually interprets the signals it gets. This is all about how it translates a physical thing, like heat or light, into a useful electrical signal that a computer can understand.
First, there's sensitivity. A super-sensitive sensor is kind of like having really sharp hearing. It can pick up on the absolute tiniest whisper of a change in whatever it's measuring, and it'll yell that change out with a big response. A sensor with lower sensitivity, well, it needs a much bigger change before it even bothers to react.
Now, in a perfect world, every sensor would be just like this, perfectly linear. What that means is its response is totally predictable. You double the input, you double the output. Simple. It's a straight line relationship, which makes the readings super easy to interpret.
But the real world is messy. A lot of sensors are non-linear. Their output doesn't follow that nice, clean, straight line. It follows a curve. Now, this doesn't mean the sensor is bad. It just means you need some more complex math and software in the background to translate that curvy output back into a measurement that makes sense.
Next on the list is resolution. And resolution is all about detail. Think of it like the smallest, finest print a sensor can possibly read. It's the absolute tiniest little nudge in the input that the sensor can actually notice and report back to you.
So, for instance, a high-resolution thermometer wouldn't just tell you it's 25 degrees. No way! It could tell you it's 25.001 degrees. Now, that level of detail is absolutely critical for things like scientific experiments or medical devices, but yeah, it's probably a little bit of overkill for your thermostat at home.
Okay, so we've talked about how these things should behave in a perfect world. But now, let's get real. Let's talk about the glitches, the imperfections that can pop up in a sensor's performance over its lifetime.
First up is this weird one called hysteresis. It's almost like the sensor has a bit of a short-term memory. The reading it gives you for a specific value, let's say 50 degrees, actually depends on which direction you came from. So the reading you get as the temperature is rising to 50 degrees will be slightly different than the one you get when it's falling back down to 50. Kind of strange, right?
And then there's drift. This is that slow, gradual change that happens over a really long time. Even if the input is held perfectly constant, the sensor's parts just get old, they age, and its output will slowly drift away from where it started.
This is exactly why super-sensitive equipment needs to be recalibrated every so often.
All right, we're almost there. Our final set of grades on the report card defines the sensor's field of play, its absolute operating limits. You just can't ask a sensor to measure something it wasn't designed for, and these specs tell you exactly what those boundaries are.
This one's pretty straightforward. Range and span. The range just tells you the minimum and maximum values the sensor can handle. So for this thermometer, it's -10 up to 50 degrees Celsius. The span is even simpler. It's just the total distance between those 2 points, in this case, 60 degrees. Easy, but you have to know it.
So after going through all those technical details, let's bring it all back home. Why does any of this matter? What does reading this report card actually tell you about the real world?
Well, here's the bottom line. Understanding all these characteristics lets engineers pick the right tool for the job. And for us, it helps us understand the limitations of the technology we use every day. It helps us predict how a device is going to behave, and maybe even why it might fail sometimes. And honestly, it just gives you a much deeper appreciation for the incredible engineering that's packed into everything around us.
So, now you know how to read a sensor's report card. And you can start to think a little differently about the tech in your own life. What about your home thermostat? Is it super sensitive? Is it precise, but maybe not all that accurate? What's the story its tiny little sensors are telling you about the world they measure?